All right, welcome. Today we're going to begin the study of plate tectonics, which, as you could probably guess, is the study of what we call tectonic plates. And really, this is my one of my absolute favorite things to study because tectonic plates are the reason that the Earth has the features that it does. The mountains, the really even the deserts and the volcanoes and the earthquakes and all this everything that we see around us is in one way or another a result of tectonic plates. So we're going to learn about how that is possible today. This study, this knowledge about tectonic plates is really pretty new. 100 years ago, we had no idea that tectonic plates were even a thing. People just figured it was, a coincidence. Wherever there was an earthquake, there just happened to be an earthquake, or a mountain. And they had no idea that there was any science behind it. But in the last 100 years, we started to put these different evidences together. We started to put these pieces together into an explanation about why we have these things. So we're going to talk about several of these different pieces of evidence today. So evidence number one, people started noticing a pretty long time ago, really, that the continents fit together kind of like a puzzle. Like if you were to cut out South America and slide it on over here next to Africa, this edge would match pretty well with this edge. And I can even see argument that if you took North America and you slid that down right in here, that could fit as well. And so people were noticing that the continents were shaped kind of like puzzle pieces ever since complete maps began coming out. So as people noticed this, they thought it was cool, thought it was interesting, but there was not really any explanation behind it. It was just must be coincidence, they thought. But then we started finding other pieces of evidence as well. So, for example, fossil patterns. People would find fossils of this ancient species right here, and they would find the exact same species over here, and they're like, wait a second, the exact same two things, a whole ocean away from each other. How did that happen? So they started creating hypotheses for how this is possible. How could there be the exact same species on both sides of this ocean? And so the first false hypothesis they found, they guessed that they must have swam across, because how else could you explain that? So that was proposed. There's multiple fossils across these two different continents because the animal could swim. Well, the animal that we're referring to, or at least one of them, because this happened several times, one of them was Lystrosaurus, and it was not the best swimmer. I mean, look at those stubby little legs. No offense, dude, but I don't think this little animal would have very much luck swimming across the entire Atlantic Ocean. I mean, where is it going to find food, right? It just doesn't look like it's built for swimming, and that's because it's not. So that hypothesis just does not pan out. There's no way that's accurate. So scientists are like, all right, let's find another hypothesis then, because we got to be able to explain this somehow. So their next false hypothesis was land bridges. So these, whoops, I've inserted these orange pretend land bridges to explain how these animals must have been able to cross the ocean. So they said, well, maybe, hundreds or thousands of years ago, we would have these bridges, or these kind of land bridges, I guess. I guess it's self-explanatory, that used to connect the continents. But for some reason, they existed before, and the animals were able to cross from, let's say, South Africa over to South America. And since then, the waves of the ocean have knocked away all the land bridges, and so the land bridges don't exist anymore. But that's why those animals were able to cross. And honestly, that's just kind of a shot in the dark. Like, sure, if there were a land bridge, they could have crossed, but we have no evidence whatsoever that there was ever a land bridge that crossed that. So really, that's just kind of a random guess. Then along came a man named Alfred Wegener. I say Wegener because he was German, and that's how you say the W in when you're speaking German. So Alfred Wegener, he comes onto the scene, and he starts collecting these different evidences that other people have started to discover, and he starts connecting the dots. So he's like, what if we take this idea of the continents fitting together and we combine it with the idea of these fossils being located across many different continents. So he kind of builds this first model of what we now call Pangea, which means all the continents being put together. And these stripes of color show where the fossils are found. So this red stripe right here, that represents one type of animal and where we found its fossils. The purple represents another. And as you can see, there's a connection between where these continents touch each other and where the fossils are found. So putting the putting the continents together based on shape also just magically lines up where these fossils can be found. And so he's like, okay, there's got to be something here. Like, there's no way that's a coincidence. These continents must have moved. And guess how that was received by his peers? They literally laughed him out of the building basically when he proposed that continents could like float across the ocean and move over time. They basically said, Alfred, you're a darn fool and get out of here. It nearly cost him his career. It cost him all respect from the scientific community. He basically became an outcast because of how stupid, and I say that in quotation marks, his idea that continents could move was. But he stuck to it, and he also put together other pieces of evidence. So here we go, round three, rock formations. So geologists were studying where there's gigantic outcrops of rock and ancient coastlines and ancient glacier deposits. And when you add up that data and you do kind of the same idea where you connect the continents based on their shape, you have a lot of success in matching up these features. So let's look at these individually. This X marks the spot granite formation. What that's saying is there's a large area that's covered by a specific type of granite rock. Okay. And it's found right here on Africa, and it's also conveniently found right here on the tip of South America, right up here in this corner. And that just so happens to match, right? Coincidence? Well, maybe. But then look at this evidence from an ancient coastline. So long, long, long ago, millions and millions, if not billions of years, there was an ancient coastline that went right through this area. So if you line up the evidence of where this beach or this coastline used to be, the line matches up perfectly across these two continents. If that wasn't enough, we've got one more for you. This whole purple area with all the little dashes, that represents what's called a glacier deposit. So when glaciers move across the land, they move fairly slowly. They kind of grind their way across the ground. They're gigantic, hundreds of millions of pounds worth of ice, and they just grind their way downhill across the ground. And as they do that, it leads a it leads to a lot of scratches in the ground. And there's other evidence as well of that. So when you add up all these glacier deposit areas, it just so happens that it lines up perfectly between these two continents. So if you were doing a puzzle and you saw these two pieces, it would be hard to not connect them, right? It would be hard to argue that they don't go together. And so, again, Alfred Wegener, he stuck to his guns and he believed that these continents could move. The problem was he just couldn't prove it yet. So here is another evidence of the plates or the existence of tectonic plates. So we have earthquakes. So anywhere you see a red dot, that represents an earthquake that has happened. And the bigger and redder the dot is, the more severe it was. So you see a lot of severe earthquakes right in this area and again right over here. And then you see these little patterns of lighter colored dots that represent smaller earthquakes. So people before just thought earthquakes were completely random. But if you start mapping out where all these earthquakes take place, you do start to see a pattern. There's definite lines that exist where the edges of these plates are. And again, back in Alfred Wegener's day, we had no idea that the Earth was made up of plates. But we've just in more recent days discovered this technology, and we've created these maps that allow us to see where they're happening. So, look familiar? These two maps are honestly very similar. This one shows where the volcanoes of the Earth are. And again, before people just thought it was random. But now you can see definite lines. I mean, look at this line following up here by Alaska and down this coast and along this coast. Same thing over here near Japan. We have these obvious lines where there is something going on that's creating a lot of volcanoes. And then you have these huge areas like right out here where there's nothing. So this kind of shows us where these plates are divided up, where the edges are versus where the centers are. And this is all stuff they didn't know about, 100 years ago. So this is what Alfred Wegener proposed. The continents are drifting. They are moving, and that explains why we're finding fossils, why we're finding different rock outcrops, why we're finding the glacier thing. That's why they fit like a puzzle, because they used to all be together, but they have drifted apart. Um, that was his idea, and again, everyone else was like, "Yeah, okay, that's nice, but you're gonna have to prove it." Okay, we're scientists. You can't just make a claim with no evidence whatsoever. This video is truly a gem. We're not going to watch it as part of this video. You will see it many times in class, I promise, if you haven't already. But that's why that's in there. Sadly, Alfred Wegener did not live to prove his idea. He didn't collect enough evidence. He was not able to come up with a method that would explain how the continents are moving. He came up with a few kind of sad ideas. None of them panned out, and so he wasn't able to prove his idea, and he died when everyone believed he was kind of a failure. He kind of died in shame a little bit. Have you ever had anybody doubt you, but then later you were proven right? It's sweet justice. It feels amazing. Sadly, Alfred Wegener did not get that. But then a little while later, we had World War II going on. And at the beginning of World War II, around that time period, this is what people thought the oceans looked like. So here I have a terrible creation of mine that shows kind of the continents up here, another continent up here, and then the basin between was basically like a gigantic bathtub, and it was completely smooth and featureless. It was like the smooth of the bottom of the bathtub, and there was really nothing down there. So that's what they thought. Around that time, at the beginning of the war, the Germans were winning World War II to start because they had one huge advantage. They had invented submarines. So while everyone else was just fighting each other on the surface with these gigantic expensive boats, they were going underneath the water with these submarines, and they were sinking American ships from beneath. And it was a huge advantage. It looked like the Germans were going to absolutely dominate in World War II, and things were not looking good for the United States and the Allies. So the military developed technology to locate the submarines. So we developed sonar so we could fight back. And sonar is this technology that sends waves down beneath the water, and then it measures how long it takes for them to bounce back up. So you send it down, it hits something solid, and then it bounces back up and it is received by that same ship. And so if you know how fast the wave is traveling, you know how deep the ocean is beneath you. And so you also know if there's a gigantic submarine beneath you. So we were using this sonar technology to locate the submarines, and this played a huge role in the United States and the Allies overcoming those German submarines that were so devastating to begin with. Then, after the war, we realized we could use this technology for more than just locating submarines. Scientists were like, hey, if you're not using that anymore, can we use that to actually map the bottom of the ocean floor and see, what's going on down there? And so instead of the gigantic smooth bathtub, what they realized was that it actually was as diverse um, and as interesting as the surface of the earth, or I should say the land part of the world. It was not a smooth bathtub. There was mountains, there's valleys, there's canyons bigger than the Grand Canyon. There's mountains that are more impressive than Mount Everest. It is wild down there, and the sonar was able to show us that. So we got a completely new idea of what the bottom of the ocean actually looked like. And that started raising questions like, what's causing those mountains? What's causing those big valleys? Why is there a trench right here, right off the coast? So we had to start taking these things into consideration. One other thing we have learned since the days of Alfred Wegener, Evidence number 6. The age of the ocean floor is not the same everywhere you go. Now, this map is kind of confusing because your eyes tend to go right to the color, but the land here is the gray part, right? You can see North America, South America, Africa. The color that you see out here in the ocean is telling you the age of the ocean floor. The dark red is showing you the youngest, like brand new, not very old rocks. We can put a date on these rocks, and the scientists can tell us how old they are. The purple and the blue represent the oldest rocks. So you see, like, there's some really old rocks right off the coast, like the east coast of the United States. There's some old rocks right here on the other side with Africa. But you see these stripes of bright red and orange and yellow that represent the brand new rocks. And that didn't make sense unless you start to believe that the ocean floor, that brand new ocean floor, is being made up um, at these boundaries that run all the way around the world, and then it is it is destroyed when it actually hits a planet and is subducted or it moves beneath that continent. And so that's the idea that came forth because of this. But this is one of the evidences that shows us that these plates must be moving, because if there's ocean floor being created, that means there must be ocean floor being destroyed. Otherwise, the world just would just keep getting bigger and bigger and bigger. All right, evidence number 7, mountain ranges. So mountains aren't random. They form these ranges or these chains of mountains. And if you look at a map, you can see where they fall. And it just so happens they fall in those same locations where there's earthquakes and volcanoes and all that other stuff. So that is evidence number 7, the existence of mountains, not just in random locations, but in specific areas connected to each other, forming chains. And last but not least, the most undeniable evidence we've got: GPS technology. So in modern days, we have satellites in outer space that can literally just watch and measure these continents over time, and we can literally watch the continents moving year by year. Are they cruising? Should you buckle up and put on a seatbelt so you don't get knocked off? No. In fact, those GPSs calculate that the continents are moving about an inch per year. So, yeah, we're not exactly cruising, but it does show that without a doubt the continents are moving. So, how is Earth's mantle like this lava lamp? This is the driving force behind why the continents are moving, that Alfred Wegener desperately wanted to find, but he never could because we didn't have the technology. If you ever watched a lava lamp, you see rising and falling the circulation of this goop or this jelly, whatever's in there. And you know that there's a heat lamp at the bottom, but there's no heat lamp at the top. So if you have ever heard of convection or a convection current, you understand that this lava lamp works because heat rises. And so if you're this ball of jelly down here on the bottom and you're getting heated up by this lava lamp, you actually become less dense as you expand just a little bit because of the heat. As you become less dense, of course, you're going to rise. Then once you get up here to the top, you start cooling down because you're far away from the heat lamp. And once you cool down, you're going to condense. And what happens to more dense things? They sink, right? So you have this cycle happening over and over and over. And in a lava lamp, it happens pretty quick. Like, you can see some action going on every few seconds. Well, the Earth is very, very similar to this inside the mantle. It doesn't move nearly this quickly. Things are moving extremely slowly, but they're moving. And so as you have these cycles going, or these currents slowly moving, that's like a wheel underneath the crust. And it's slowly churning, and it's moving those pieces that are kind of floating on the surface. And so that's why we get an inch a year worth of movement. And that's why those plates move around. It's mantle convection that has the power to move the plates of the earth. And it's pretty powerful. Even though it's slow, obviously it's got to have a lot of power if it's going to move entire continents, right? So this is the secret that Alfred Wegener was looking for. He just didn't live at the right time. But we're glad he did live, because he kind of got the ball rolling, and he gets credit for coming up with the first idea of the continents moving.